Okay, this will be a condensed version of what we have done in the tutorial this week. I will just still cover the main points and trust that given the fact that you have attended the tutorial, this will be straightforward, not needing much explanation. I will, however, will try to explain things as best as I can, but the clip is going to be short simply because I don't think we need to extend it for as long as the time that the tutorial normally goes for. So in this week, what we have done is look at how to calculate angles using Microsoft Excel. I will start off by presenting to you the two types of angles we define in biomechanics, which are the absolute angle and the joint angle. On the left-hand side, you see the absolute angle, which is what you guys know to be the angle in between the segment and the horizontal positive line. So from that positive horizontal line goes anti-clockwise until it matches the segment. During the tutorial, we mentioned that every segment has two ends, the proximal and the distal end, and that this horizontal line is always traced on the distal end of the segment. And as we can see here for the phi, we have the same scenario. We trace the horizontal line on the distal end of the segment, which is in this case the knee, and from that horizontal line anti-clockwise into the segment defines the phi segment. And for the leg is the same thing, distal end, horizontal line from the anti-clockwise to define the leg angle, and for the foot is the same process. Distal end, toes, horizontal line, anti-clockwise until it meets the segment. Right on the other side, what we have is the definition of joint angles, which is the angle in between two segments. So in order for us to define a joint angle, we need to first of all have the segments being properly defined. For every segment, such as for any joint, pardon me, such as the hip, the knee, or the ankle, there are two arms to that angle, which is what we call the proximal segment and the distal segment if we focus on the hip. The way this angle is calculated is by projecting a straight line from the proximal segment past the joint. So the angle that is forming in between that line and the distal segment is the hip joint angle. And likewise, a line is projected from the proximal segment of the knee angle past the distal end, and the angle that this line makes with the distal segment of the knee joint defines the knee joint angle, and so forth. As we have explained in the tutorial, this is an advantage simply because when the person is straight up, both the hip and the knee angle will be zero, which corresponds to the neutral position. So it makes it easy for us to interpret data such that when your joint angle is close to zero, we know that the person is in a neutral position. And when that angle increases in value, we can see that the flexion of that particular joint is also increasing. And that's pretty much it for those two things. In the case of the ankle angle, because we assume that the person being upright, the foot will be horizontal and flat, what we do to make this match to zero is just we take away 90 degrees to the calculation of the ankle angle. And that's the definitions for absolute angle or segment angle, which is the angle in between the horizontal and the segment going in an anti-clockwise direction, and the joint angle, which is the angle in between two segments. And we defined these angles such that the neutral position will see a 0 degree angle for the hip, knee, and ankle. But this will get clearer when we do the calculation in Microsoft Excel. The rationale is quite simple to calculating an absolute angle. So we define a coordinate system first of all, and with this coordinate system we locate a point and a second point, which potentially will be the proximal and the distal end of a segment that we will define, but that will be seen later on. So let's stick to the basics here. So this point in red defines that vector, and the point in blue defines another vector. So we have two vectors being defined, and between them we can link the two endpoints of these two vectors by a third one, which is the vector in green. So if we name these three vectors that we have, such as with A, C, and B, what we can establish from this diagram is that the vector C is equal to the sum of the vector A plus the vector B, which is what we have here. If we rearrange this equation, we can say that the vector B will always be equal to vector C minus vector A. And this simple thing is what provides us with the tools that will enable us to calculate segment angles and, as a consequence, joint angles, that we will see in the next slides. To calculate a segment angle, we need to follow two steps. The first one is to define the segment, pretty much in the way that we have seen in the previous slide. That is proximal end, minus distal end, and that's pretty much it. That's the first step, is to define the segment. The second step is to calculate the angle, straight onto it. I will use some data, the same data that I have used in the tutorial to make this point, but should be quite clear after doing this presentation to you. So let's have coordinate system again, and let's have within that coordinate system a heap marker. And that heap marker will be identified by its coordinates. In this case, let's assume that is 8,8, which is the same value I have used in the tutes. And equally, let's have a second point, a second marker, says the shoulder, and that shoulder will be entirely defined by its coordinates. And let's say that is 11,12, which again is the same example that I have used in the tutorial. Knowing these 2 points, the shoulder and the hip, we can define the trunk segment, which is presented to you. And the task will be to calculate the angle of the trunk. And when we say the angle of the trunk, we really mean the segment angle of the trunk, or the absolute angle of the trunk, which is the same thing. And as you know, this angle is calculated from the positive horizontal going anticlockwise onto or into the segment, which is what we have here. So we just need to follow the steps that we have shown you already. The first step is to define or to calculate the trunk segment. And the trunk segment, as we have enunciated earlier, would be the shoulder marker minus the hip marker. And given the fact that we have the values for the shoulder and for the hip, we just replace them. And we say the trunk is 11,12 minus 8,8, and which means that the trunk X will be 11 minus 8, and the trunk Y will be 12 minus 8. That is 3,4, which is what defines the trunk segment as a vector. That means that the horizontal value for the component of the trunk is 3, and the Y component, or the vertical component of the trunk segment, is 4. And that those two coordinates will form a right angle triangle, and we can therefore calculate theta, that is the segment angle, by using what you already know. So that angle is calculated as theta equals the inverse function of tan, open brackets, vertical coordinate divided by the horizontal coordinate. Since in this case we have that the Y coordinate of the vertical is 4 and the horizontal is 3, just simply sub in those values and we obtain the angle to be 53 degrees. And that is what the process is quite simple, but straightforward. We just need to understand what we are doing. And I trust you guys do that, but this will help to understand further if things are not clear. So to sum it up, what we say is that the process of defining a segment, it is just doing the proximal end minus the distal end, which means in practical terms that the x coordinate of a segment is the x coordinate of the proximal end of that segment minus the x coordinate of the distal end of that segment. and by extension, the y coordinate of the segment is the y of the proximal minus the y of the distal. Once we calculate the y of the x of the segment and the y of the segment following this, then we should be able to calculate the angle of the segment by just implementing the inverse function of tan open brackets y on x, and that's pretty much what the whole process is. As we have had in the tute, there is two scenarios, one in which your segment looks something like this, where both x and y coordinates are positive. And when this is the case, Excel and your calculator will do a good job in calculating this angle pretty much in the same fashion as we have done in the previous slide. When the x was 3 and the y was 4, we got 53, and that's easy enough. When that is not true, that is when your x coordinate is negative, such as this case, and the y coordinate is positive, which is something that you would potentially encounter during the course of this unit, this formula as given won't do a good job, simply because when it carries out the calculation, it virtually extends the line of your vector downwards and chooses to calculate or to output the angle underneath the horizontal axis and that extended line. So it gives you the supplementary value of what you really were meant to have. So when this is the case, and because we know these two angles are supplementary, what we do, we just add 180. And since we are operating in Excel, we will have to add pi, which is the equivalent of 180 degrees. So for these cases, that is when your x coordinate is negative, we will have to use this formula. The angle is equal to shift tan or a tan y on x, but adding pi to it to rectify for this negative angle that you are likely to have. This is not to say that an angle cannot be negative. An angle, of course, can be negative. But in this case, since we interpret correctly the meaning of an angle that is from the horizontal line going anti-clockwise onto the segment, this angle cannot be negative. And this anomaly occurs again when the x coordinate is negative. But in some instances, your angles can genuinely be negative. So don't think that because an angle is negative, it is wrong. You need to look at things in the context of your situation and assess what kind of coordinates you have to make that call. So essentially, we need to combine these two equations. We are going to use the one on the left when both the x and the y are positive, and we are going to use the one on the right when the x is negative. So instead of having to debate as to which one to use, we choose to use the if statement that allows us to have the two possibilities. That is, if your x is less than 0, as in which is the same to say as if the x is negative, then use the equation on the right, where you need to add the pi to your equation. That is, if x is less than 0, do a tan y on x, but add pi at the end of it. But if the x is not less than 0, that means if the x is positive, then do the equation that is written at the end, because that will contemplate for this scenario. So instead of you having to decide when to use this equation or this other equation, Excel, by the use of the if statement, will use a logical criteria to decide whether to use or whether to add pi or whether to leave the equation as is. And that's pretty much what we are going to do in Microsoft Excel. As a way of summing up, I presented to you during the tutorial a kind of a workflow. So we start off by having segments. That's the first thing we do, and that's what we have outlined earlier. The first step is to define the segments. The second step is to define the segment angle using the if statement formula. And once that is done, we can calculate the joint angles, which, as you will see in a minute, is extremely simple. So that's pretty much with this. So what I will do now is share the Excel document to show you how the whole process is completed. What I have done compared to what the tutorial activity was, I have added a couple of rows at the top just to enable me to actually show you each of the 3 steps that I'm following. Okay, so what I need to do here before we do that is to, I will just, okay. I'm not as organized as I thought I was. Pardon me, I just need to do a little thing here. Okay, now I'm ready here. Okay, what we do, we first of all need to define the segments. So you don't really need to include these top two rows. I'm just doing it for the purposes of showing you exactly what went on. As always in Microsoft Excel, it is important that you have a systematic way of approaching the challenge that you have at hand. In this case, we need to define the segment. That's why I put this. So that means that here we will have the segments that we can define out of the shoulder, hip, knee, ankle, and toe. The first segment that we can define will be the trunk, and that is the segment in between the shoulder and the hip. The second segment that we can define will be the thigh, which is the segment in between the hip and the knee. The next segment is the segment leg, which is in between the knee and the ankle. And the last one is the foot, which is defined in between the ankle and the toe. I'm just tidying it up so it looks good and easy to work with. And I would always encourage you to be systematic in how you prepare your worksheet so you can work with comfort. 50% of the work is really laying out your spreadsheet so you know exactly what you're gonna do. And since you would know that, the next bit is just to implement that, which should not be hard if you understand what you're doing. So let's have the trunk angle. That's the heading that I have there. I have the thigh, the leg angle, and the segment foot angle. And finally, we will define the joint angles, that is the angle in between the trunk and the thigh, which would be the hip joint angle. The angle in between the thigh and the leg will be the knee joint angle, and the angle in between the leg and the foot is the ankle joint angle. And to distinguish this trunk from the coordinates, what we do, just put something, and my choice is to always use the Greek letters or the Greek symbols. Type lowercase q, change the font to symbol, and I get theta. And I do the same for the joint angles. I use the letter F to distinguish this from this, in that this would mean to me that it is a joint angle, and this would mean that this is a segment angle. And sometimes it is important to make that distinction, because sometimes we might refer to segment angles and sometimes we will refer to joint angles, and they are not the same thing. Okay, defining the segments, as you would recall, it is just proximal minus distal. The X of the trunk will be the shoulder X minus shoulder hip. Because this pattern will be repeated throughout the calculation of the segments, what we can do here is just to drag that across to save us time. And also drag it down, because there is no need to type in the same equation 100 times. So that is the segments defined are done here. So again, just to reiterate notion, the trunk segment X coordinate is shoulder X minus hip X. And the trunk Y coordinate would be, as we have stated before, will be shoulder Y minus hip Y. And the same notion applies to the rest of the coordinates. Thigh X coordinate will be hip X coordinate minus knee X coordinate, and so forth. So that's what it is. Again, as we have done in the tute, what I will do here, I'm just going to copy the formula from the PowerPoint presentation. That's the formula for the angle, and we are going to follow that. We are going to calculate the trunk angle, which means that we are going to use the X and Y of the trunk to do that calculation. We start off by copying this formula and say equals if X is less than 0, it means that this X here refers to the X of the trunk, which is this. So if that is less than 0, then do a tan This y here refers to the y of the trunk divided by the x of the trunk, and we add to it pi. So that's the first condition. So if the logical test, if M5 is less than 0, then Excel will do what follows within those two commas. But if this logical test is not met, that is if M5 is greater than 0, then Excel needs to know what to do, and you just say to it. Then if that is not true, then what you are going to do is you are going to do a tan y of the trunk divided by the x of the trunk and forget about it. So you have the two possibilities that x is negative, then Excel operates the first equation that is in between the commas. If that is not true, then Excel will do that. And that will give you the angle of the trunk in radians. If we want this to be in degrees, which probably we do, we just insert the word degrees in front of the if and make sure that you match the brackets at the end. Obviously, you can all see that Excel uses color coding to make sure that the brackets are matched. That is, you have equal number of brackets open, you have equal number of brackets being closed. If that is not the case, some of you might get a num or some of you might get an error message. Always check for it. Another place where students tend to make a mistake is sometimes instead of using plus, they use something else. Say times or equal or something else, and that doesn't work. Another mistake students tend to make is that instead of selecting the x of the trunk, they type x. And if that is the case, then Excel will not be able to operate either, because x to Excel means nothing. So you need to point it to the right cell. Okay, so if that is the case, then you should be confident that your data is right. And I will just do this for the next, actually, something that might save you time is this. If you click on the cell and copy the formula from the toolbar, copy that, Control C or Command C, enter, you haven't done anything, we just paste it onto the next cells. And what we can do here is just to redirect the formulas to the correct cell. So if I'm working with the thigh, the thigh X is on O, not on M. So I just change that to O. So I'm directing the formula to the X coordinate of the thigh, and I just need to redirect the Y coordinate of the trunk to the Y coordinate of the thigh, which is on column P. So I just change the N for P, and that is done correctly. So you don't have to be typing the whole thing again. And so we do that for the leg, which is between Q and R. So that should be Q. Change that first. And the N, change it to R. And again, that saves us time. And same for the foot. The foot is between S and T. So this, instead of being M, should be S. Change that to S and that to T. So that's something you might choose to do if you want, because that will save you time. So once that is done, you can drag the whole thing down, but instead of dragging it down, what I will do, because I have the first row done, I can do the first row of the join angles and drag the whole thing at the same time instead of dragging it so many times. So the hip join angle is calculated as the thigh minus the trunk. Done. The knee join angle is the angle of the thigh minus the leg. I'm not making a mistake, that's how it is. And the ankle join angle is the foot minus the leg minus 90 degrees, as we have said at the beginning. Once that is done, we can select the whole thing and drag it down. And the calculation is done. And that's what the process of calculating, I will get rid of this, the process of calculating join angles and segment angles is. So with that, I will end the clip. in order not to make this too big. And if you have any question, by all means, do ask me. Shoot me an email, send me a text, and whatever you need to do, just let me know.